Awesome, thank you. So can everybody hear me?
Yes.
Great. Okay, so I'm going to make these slides available at the end, and but let me start sharing my screen and get moving. All right, so today I'm going to be presenting on hands-on with GANs, adversarial examples, and other advanced machine learning topics in NetsBlox. And okay. So before I jump into the hands-on activities, which I expect to spend most of the time doing, I just wanted to give a little bit of background of kind of what motivated this work and things like that. Now, anecdotally, some of this, me thinking in this direction started from actually SnapCon in Heidelberg a few years ago, where I was listening to some of the talks and some of the ways where Snap had been used in math, and was thinking that with the appropriate abstractions, you could probably still teach more fundamental machine learning concepts. So I started playing around, and actually during that conference, I wrote an automatic differentiation library for Snap. So it's all in blocks. There's no JavaScript at any point. So the performance is a little bit worse, but the nice thing is that it's very you can lift the hood on any of the things that are going on, and it gives you all the same type of flexibility that you get with any like PyTorch or TensorFlow or things like that. At least in terms of being able to use arbitrary mathematical operations that you define that someone at some point defined a derivative for how to compute the gradient, and then it just moves forward. If you're not familiar with some of these things, like again, AutoGrad libraries and things, don't worry about that too much. The big takeaway is just one of the things that I'll be exploring and talking about in this talk is this kind of question that I've been kicking around about basically how much can we lift the hood on AI and machine learning when using it within a block-based environment. So there are a lot of really cool projects that are using off-the-shelf models, but the students don't have any ability to open them up or probe inside. So the algorithm in the model is generally a black box for these. And I'm wondering how much this thing can be opened up. Now, this project specifically that's funding it is actually focused on teaching AI and machine learning from a cybersecurity standpoint. So the nice overlap here is a lot of exploiting vulnerabilities in cybersecurity kind of requires some understanding of the internals, at least enough to exploit it. So you can see that there's a little bit of a synergy there. And so my goal has been mostly, again, to present algorithms and models in an interactive way so that they can still learn or gain more intuition about these fundamental machine learning concepts through doing and building and stuff. Now, most of the activities that we're going to see are structured as Parsons problems. So a lot of times, just to try to help scaffold more, just because we're trying to expose even more, to try to still make it achievable. We first, introduce or discover the algorithm, then outline it at a high level, then implement it as a high-level Parsons problem, or you can think of it as like a Parsons problem of the sub-goals, and then implementing low-level details. But again, we'll see all this more when we get into the concrete examples, but I just wanted to at least mention it, or give you some context so the rest of this can make sense. Now, a brief introduction to NetsBlox. So this is using NetsBlox, which is an extension of Snap that you may have heard about a couple times already. In case you haven't, NetsBlox is a Snap extension that was designed to make advanced concepts more accessible to novices. So some of the primary things that it uses, or the kind of two main things that it really adds, at least in terms of blocks, these are the only things, are remote procedure calls and message passing. Now, this even just using these two networking abstractions opens up really a bunch of features, a few which covers or which supports or makes most of these possible that I'm about to list off, but there are a couple that are certainly kind of just built into the environment itself. But anyway, some of these features include things like cloud variables. You can create Alexa skills. You can control virtual or physical robots. You can do cybersecurity with those virtual and physical robots. You can use your phone as a sensor. If you saw Devin's talk earlier, so you can use your phone as a controller to control your game in NetsBlox, or if you want to start combining these, you can use your phone as a controller to control robots playing a game, both virtual or physical or whatever. And then of course we have undo and collaborative editing capabilities and support for auto graders kind of built in. So now jumping into the main kind of focus of this talk is really on teaching this AI machine learning in NetsBlox. So the fundamental question here is, and again, I've kind of already mentioned this, but just try to say it more succinctly. Can we teach AI machine learning concepts in a way that lifts the hood and allows students to interact more deeply with the algorithms and models? So can we allow them to kind of tinker with them and gain intuition and sort of, again, get this more of hands-on interaction with the actual algorithms and the models themselves? So some of the activities that we've been designing or to this end are listed here. So kind of starting with an introduction to thinking about AI and some of these vocab to start with. You'll notice that a lot of these, the main bullet point here is the activity, the sub-bullet is like the kind of main concept that we're trying to teach, though of course there are others there as well, but just highlighting kind of a core concept. So since NetsBlox has networking capabilities, the first couple, are using like chat applications, or you can do denial of service and things like that without just having to talk about it, but you can actually build servers and have all your students send messages to them and then see how you can wreak havoc. So we have like we have a bunch of different things here. The first few are relatively simple. Introducing some of these AI concepts, and then decision trees, where they actually implement the decision tree building algorithm, where you're just and we can get into those as well. But for this talk, for the sake of time, I'm just going to talk mostly about these bolded ones. Time permitting, I'm happy to go into any of the others, but I figured selecting these three already is maybe a little bit optimistic, so we'll see. All right, so let's start jumping in. So one of the first activities that we have here is this moderated is just another introduction activity to some of these concepts of machine learning. So this is our starter template, which is actually just a simple chat server. And here, if I start my, let's see, one moment here. All right, here, one moment. This is just a simple chat client here. And if we connect to say, let's see, I'm going to connect to chat server at Brian. And now I can actually start sending messages. And if anyone else wants to join, I can pull up the chat here. All right. So if anyone wants to join and actually use their own chat client and stuff as well, I posted a link in the chat. So basically, if you click on the link and then press C to start with, and type in this variable value here, chat server at Brian, then you should be able to see messages and we should be able to chat with one another. So this is a simple starter kind of template, or where we start from. But the end goal is to use, actually I can just build it here. So the main goal here is to use some of these RPCs that we have available. Specifically under language, we have parallel dots, which does a lot of natural language processing. So you can do things like get whether or not something is considered like abusive text or things like that you might want to filter out. So we can see here that this is 99% confident that this is abusive text. So you can do things like filter it. Usually we're focusing there on the client side, but basically you'd be able to when you receive a chat message, you can do things like filter out something that seems that rates high as abusive or not. So so we would just say this and let's put a little if statement in here. All right. So one second, let me pull a quick, I can't remember if I have it here already. Okay, here we go. Max using. All right, so we're going to get the, here we go, max of these. It's going to give me the row that has the highest sentiment, or the highest confidence. And if I get the first value, this is the class name. So I can just make a quick block. Is abusive, message. Make this the text, and this is just going to report if this value is equal to abusive. Anyway, so now we can just check to say that if the message that we received, oh, 1 second, I realized I made a little mistake there. There we go. If something is abusive, then we can change the message, the text, to just be like omitted. So we can change message to omitted. So now if I say, I hate you, we can see that it's been filtered out. So anyway, so that's just a really simple way to kind of get started and start talking about these basic concepts like, anyway, I'm hoping they were either saying omitted or just I hate you, but maybe they're just really angry today or not enjoying my talk. I don't know. So, so this is just a really simple way to get started with some of the built-in models. So this isn't getting into some of the exciting things yet where we're really lifting the hood, but just trying to give an introduction to some of these AI concepts. So people can start talking about things like classification and how this might relate to cybersecurity or things like that. So that one again is pretty simple. But now let's jump into something a little bit more interesting, specifically gradient descent. So before we start talking about gradient descent, what we've been starting with is kind of in the spirit of turtle geometry and everything like that, has been this game called Find the Minimum. So find the minimum, I'm going to post it here. So if you click on this link, you will you'll get this little polar bear that will say there's an invisible function here, and we're trying to find the minimum. And clicking on the stage will tell you the value at that point and the direction of the slope. So if I click somewhere, we can see that there's a green dot here. So probably want to keep going this direction. This seems good. Oh, maybe there's something right here. There we go. Found it in 6 clicks. Not to give away the answer to anyone else who is playing, but it will create new functions, and then you still have to find the minimum of this new function, and so on and so forth. So basically what we're trying to do here is start introducing this idea of optimization, and really machine learning is optimization, because we have these functions that we're trying to minimize, and then we can start asking questions like, what would it mean to find the minimum if this function represented like airline ticket prices or number of followers or viewers on Twitch, or whatever it is of interest. And then framing this as, what if this was the error of a machine learning model, and then getting us into this idea of optimization. So, or of learning as optimization. So once we, okay, so I know I'm kind of speeding through this pretty quickly. If people have any questions, post them in the chat. I'm trying to kind of show the whole kind of approach and flow before we jump into the more advanced things, because otherwise jumping right into those things, I think would be a little bit, it's nice to give a little bit of the context so it doesn't seem like we're too unrealistic with our expectations.
You're good on questions right now.
Cool. Yeah. All right, so the next thing that we have is this registration bot detection. So the next activity that we've been doing is basically we created this simple activity where students are basically stepping in the shoes of a bot, or are trying to sign up for this or register for an account for this fake website. So suppose I'm trying to sign up for an account, I can click login. It wants me to create an account first, so I click create an account, and then I have to fill out an email address and a password, and then say create account. And it says that the account has been created. Now, what we're looking at here is actually this then after we introduce this activity of creating these accounts, then we can write code for a bot to create accounts. And then the problem that we have, again, this is all framed from a cybersecurity context, is could we train a model to be able to detect whether or not something's a human or a bot based on mouse movements. So this collects your mouse displacement 5 times a second.
Brian, I just want to point out you have 5 minutes left.
5 minutes. Yeah. Yep. Perfect. Thank you. It's so the second link resulting in an error, Ken just posted. You might want to copy paste it out. Sometimes chat or Zoom chat has weird issues of or with like not capturing. Oh, I don't see anything here. But yeah, I would just copy paste it out. I'm guessing it's a hyperlink issue. Anyway, so let's and if that doesn't work, let me know and I'll check it out further. All right, so so then let's actually start talking about classification. So once we have once we've created once we've collected this human example data and these bot example data, or these examples of bots registering for the site, then we actually can start jumping in and exploring how we could train a machine learning model to do this. So we can actually just first look at these data sets. Now these data sets are like live because this is using cloud variables. So everything's like that last example I just showed is here as an example. Oh yeah, so yeah, Christoph just commented in the chat. If you're having a problem with the earlier link, the exclamation point might not be captured in the URL. If it's Zoom by default, you have to select that as well. Anyway, so once we have, once we've kind of collected these examples of humans registering for this kind of mock website and bots, then we can actually start exploring the data set. Now this is using an extension in NetsBlox called CodeApp. And CodeApp's big strength is really data exploration. So you can start saying that you have a table of data points, and these are all the example data that we've collected. And then we have this plot, and we can just drag the columns that we want, and the figure will update automatically. And we can see this kind of grid of them. And the color coding here is a little bit hard to see. So if that's maybe too tricky, we can just also put it on the y-axis. But so we can actually start to look at, you know, there seems to be a threshold. If they get above 30, then that seems like it's most likely a human. In this area, it's still a little bit harder to figure out, but if we start looking at duration, maybe that'll give some insight as well. We can see a few of those that were difficult to figure out, certainly move to the right and are a little bit easier. But this kind of gives us an easier way to start exploring the data set. Now we can basically go down and actually start initializing a few weights and come up with a simple model for trying to classify these, where we're just basically coming up with a weight for each feature. So for the average speed and the duration, and we are just trying to figure out the importance of each of these. So we can start training a model essentially that'll take care of that will try to learn the best weights, assuming that all we're doing is taking a number, multiplying it by the average speed, and taking another number, multiplying it by the weight, adding those, and then turning it to a probability. Then we can actually just train a model to start doing this. Now this, I should maybe show more links with the, with some of the, like that from the starter template, because then you can see the sub goals. Because right now this code's a little bit complicated. It's not too bad. I mean, like you're doing the dot product, so multiplying each weight by each, you know, by the average speed, and then another weight by the duration, adding them together, turning it into a probability, and then.
Brian, sorry to interrupt. You have less than a minute.
Less than a minute. Cool. All right. So since I'm running low on time, I have a few links for some of these. But basically, what we end up doing once we've jumped into this portion, we start exploring the model itself, and then starting to start getting into adversarial examples, because basically, and I'll share the link to this blog post that I made earlier about this, or about some of the other, like the internals for this. But But basically this, one second. But basically you can actually take the derivative with respect to different properties. So once we actually have students building the models to do gradient descent, and in other words, trying to optimize the predictions. Okay, so 1 second. So trying to optimize the, anyway, too many things to show. Basically, once we have students trying to optimize the model or the weights of the model with respect to predicting correctly or the error, we can take that same concept and flip it around and say, what if we wanted to optimize a point to fool the model? And then now we start getting into adversarial examples. This visualization I have right here with my last 10 seconds, and I'm probably already over, my last negative 10 seconds, is that this is just showing a bunch of points to see how it would classify them. So you can start thinking about optimization here, like how would I make a point here darker, or how would I make a point here lighter? So really just trying to introduce this concept of gradients and some of these mathematical concepts without the challenging implementation portions and things that people can otherwise get tripped up on. So,
perfect. Thank you, Brian.